Yeah, so we have a bunch of stuff going on. We have this seizure detection project, so you can go check it out. It's essentially the results of processing training on this dataset. It's about, from memory, 600 spectrogram images like this. So you can actually, maybe when it's waking up, scroll through the images. It should be easy to scroll for this one because there's less in the training and validation set. Most of them are in the training set, so there are much more images there. You just go scroll through them. In theory, yeah, something wrong there. It's okay. Yeah, validation seems to be higher quality, like more confident seizures. So that's what the spectrogram doing during seizure. And then we have a training. It was the last time we trained, we got to test accuracy of 90%. But the one before last, we got to 96.6%. We only had 2 false negatives. So when the algorithm actually indicated a no seizure, whereas the actual data, what's called the baseline, the true, it's called, forget the name, something truth, ground truth. Yeah, ground truth was seizure. So it the 2 essentially false, it's false positive, false negatives. They are false negatives because it's negatively said it's a non-seizure, where it's actually is seizure, but it had 0 false positives, so no indication of seizure when so all the non-seizures were indicated, all the seizures were indicated as, again, I'm confused, wait, confusion matrix, that's why it's called confusion matrix, isn't it? To get you confused, but no, I'm just joking. So all the non-seizures were labeled as non-seizures, and some of the seizures were labeled as non-seizures. So those would be, false negatives. So eventually, test accuracy of 96%, average training accuracy. Yeah, so you can see it from the these plots as well. Model accuracy, so getting up to almost 100%, both for training and validation, and getting to almost 0.1 on the loss function, both for training and validation. Didn't quite saturate there, so we probably could have run for more epoch, but we already did like 70, so it should be enough. And yeah, we're showing the misclassified images. These are these 2, and you can select the run number. So then we run again, and we had a slightly poorer performance with instead of the 2 false negatives, we had 6, but still 0 false positives. And those are the examples. So this is essentially, you can see where it's going wrong. So in this case, the true label is 1, meaning seizure, but the prediction is non-seizure. And the same for all of those. Yet probably this one and that one are oddly misclassified. You can kind of see the seizure frequency in there, like slowing down, so on and so forth. You can see a better version here. This probably be a more representative spectrogram of a seizing EEG channel. So go check out this tool. It's all on IKEAs.com. You can find the link pretty much everywhere. Let's go back to 100%. Yeah, still testing our eyes, so they will highly depend on the light in the room, but test this tool as well. Let me know how you go with it, and we'll start developing in a second. Yeah, perhaps we should go over other tools, unless there's any specific questions or you want me to cover anything in particular. Actually, ChatGPT is pretty good at asking questions, so we might as well use that.